Hello guys, in this video we're going to see how to interact with the contract on the blockchain. Last video we made a contract from a template, then we divided the contract into modules in order to organize our code, and then we built the contract in order to generate our build files. These are contracts, these are the modules, and we made a test endpoint in order to just write some code, see how the code is divided into modules and stuff. So let's see how we can actually put this contract on the blockchain, on the DevNet, and how to interact with it. So first of all, let's try to change our endpoint in order to actually do something. So we have a storage called myStorage that can store a value of type bigint. Let's try to change this endpoint from a set endpoint to set storage. We're gonna give it a parameter of type bigint, and we're just going to set the storage with a specific value. So we're doing a myStorage.set value. Okay. And in order to retrieve the storage from the contract, there are two methods of doing that. First method would be to actually create another endpoint that just gets the value, but the quicker way of doing it is to just place another attribute here called view. This attribute actually functions as an endpoint, as a get endpoint, so every time we're going to call this, so this storage will actually appear as an endpoint, and we can call it in order to retrieve the value that's inside. Let's try to build the contract again. And now let's check our lib.rs file, and we can see that myStorage now shows up as an endpoint. This is actually our view. So if you want to leave these attributes without a parameter, the endpoint will inherit the name of the function. Otherwise, we can customize this. For example, give it a name, and we can do the same to this one. Let's try to do the same here. So now, if we rebuild the contract, we're gonna see the endpoint names as the custom names that we gave them. Cool. So now that we have that, we basically have a contract that has an endpoint to set a storage and then a view in order to get the storage. So now let's try to put this contract on a blockchain. First thing that we want to do is generate the Rust interactors that are going to help us do that. For that, we're going to use the command spacecraft-meta-aosnippets. As you can see, another crate was generated called interactor. If you go through it, there's a lot of code here that is automatically generated by spacecraft-meta. The most important thing are the interactor functions. So these are the actual functions that make the transactions on the specified development environment. Because as you can see here, we have two chain types: a real one, which contains DevNet, TestNet, and MainNet, and the simulator setup, which is a local blockchain that we can run in order to test various things. So first of all, we're going to try to do it on a real blockchain. Okay, let's try to add interactor. Okay, that's good. So now we can see that our compiler actually goes through this code and actually compiles it. And it's a really easy way to figure that out by just using Rust analyzer, putting our cursor on different stuff and see if it manages to understand the type of the variables. Now we can already use these generated functions in order to programmatically put a contract on a DevNet. As you already see, there's already a test that's generated. That's a deploy test. Basically, it creates a new contract interacts struct, which is our interaction struct. The new function does a lot of configurations. It uses our interactor type from the framework, and the contract interact is basically a wrapper over it, which contains the interactor, one test address. You can add as many addresses as you want, one contract code, and the state. Let's see the state. Yeah, the state contains the current contract address. It has automatically implemented the logic that whenever you deploy a contract, it will basically take into account only the last deployed address. So it's easier for you to write tests on the fly. So as you can see, we already have this test. The deploy function is called, also generated. As you can see, this function uses the interactor from the framework and launches a transaction. The syntax is basically the same as the contract syntax and also as the black box testing syntax. The only difference is that it needs an await at the end, because we're dealing with async Rust. We're actually launching transactions, interacting with the API. So let's try to run this test. You can write as many tests as you want here and basically just run each of them in order to do actions on the blockchain. Okay, so now we can see that the transaction was successful. We got a takes hash and we got a new deploy address. Now that we deployed our first contract, a new file has been generated called state.toml, and this file will basically store our latest deployed contract address from now on. So this is our first contract. If we were to deploy the contract again, that file is going to be updated to the new address. All right. So let's actually check this. Let's see if it's actually true. Just goes to random transaction. Okay, so this is our takes hash, and we can see that it's a successful transaction. Smart contract deployed. We can check the logs if we want. Yeah, it's all good. Let's also double check. Maybe we don't trust this. Let's double check the actual contract address, so we can find our contract that only has upgradable as properties and no transactions. So this is how we can quickly place a contract on a blockchain. Now let's try to not only deploy it but interact with it. Let's go inside functions, and we want basically to do the entire flow. So we have a set storage function, and then we have my storage view, which is a query. It's not a transaction anymore, it's just a query. So what we want is to be able to specify a big int value, set it in storage, and retrieve it. So in order to do that, for more customizability, let's just add this as a parameter. For ease of use, we're just going to use Rust bigint as a parameter, and then we're going to turn this type into our bigint in order to avoid these generics. So let's do it like that, and now here I can say bigint value. This is going to compile. Great. Now that we have that, okay, we can comment this for now. That's for a parameter. That's the CLI. We can also do so. Instead of actually running the tests, which is in my opinion the recommended way to do it, we can basically go inside the interactor and use the CLI and run cargo run deploy. And this is also going to deploy for us. But in my opinion, it's way better to have everything programmatically. All right, so let's think about our flow. So we have contract deployment, and then we want to do interactor dot set storage, and we need a value for that. We're going to await the transaction as well, and then we want to do my storage and await that as well. So for a bit more customizability, let's actually return this value. The framework type, and we're going to actually result value. Nonsense. Yeah, that's true, because we use the result handler returns result unmanaged. We're gonna receive a Rust big-win type instead of a big-win type. So what this handler does, basically turns the framework types into general types so that they are easier to use in a STD environment such as the interactor. Okay, so now that we return the result value, also comment that for now, it's just the CLI. Now we can, first of all, let's set up a value. So value would be let's say 15. So now we created a value of 15 in bigwint. We set up the storage value. Now we retrieve the result value from the contract, and let's try to do an assert on it. Result value and value. Let's try to clone it really quickly to see the result. Yeah, cool. So this is our flow: deploy, set storage, get storage. Let's see how that goes. It's gonna redeploy a contract. Okay, that's perfect. So the first thing that we notice is that the test passed. That means this assert is true. We can see a print of result 15 here, and that's from my storage. Yeah, this print is from the previous operation, from set storage. As you can see, there's no type returned. Actually, this return is not even necessary, because setting the storage doesn't return anything, and that's why it prints unit. And then calling my storage actually returns a bigwint, and then it prints it and returns it to us, so we can see it here. Yeah, that's pretty much how to deploy and interact with contracts using the Rust interactors. For more details, you can find this chapter of our documentations called Interactors Overview. Here you can go through everything from setting up the development environment and writing syntax and everything. Let's do one more thing actually. Let's check out our newest deployed contract address. It's going to be the same here, yeah. And let's see if we can find it on the Explorer. Yeah, so we can find our contract, and we can also find our transaction set storage. If we click on the transaction hash, we can actually see more about it. Queries are not transactions, so they actually don't show up as transactions. Cool, so that would be all for the introduction into interactors.